everyone, this is a continuation of our lesson on areas of trapezoids, parallelograms, and triangles. Today we'll be talking about composite figures and the shapes that make them up and how to find the area of a composite figure with all of those formulas you now know. So let's do a quick review of those formulas. First, we have base times height. And that base times height formula goes with rectangles and parallelograms. Remember, the base is whatever you assign it, whichever side, and the height is the perpendicular distance from the top of the shape down to the base. Next, we have 1/2 times base times height, and that is the area of a triangle. Remember that a triangle is half of a parallelogram, so we are taking half of that base times height. And last, we have our trapezoid. And remember, trapezoids have two bases. We have our base 1 and our base 2. And they also have a height, the distance between those two bases. And since half of a parallelogram can be made into a trapezoid, we're taking half of that. All right, let's get started. When I'm finding the area of composite figures, there's 4 things I need to do. First, I need to decompose the shape into familiar polygons. So I want to change it into a bunch of rectangles, trapezoids, triangles, any shapes that I'm familiar with and have an actual area formula for. Then, once I've done that, I want to fill in any of the missing measurements. So anything that is not marked, I want to mark it for myself because I might need it later. 3, I need to plan the work. So I want to make a plan as to how I'm going to solve this because there's a lot of steps and I don't want to forget anything. And then 4 is use the formulas and of course follow the plan you just made. Let's first look at this shape. Look at its features. Before I decompose, I want to say one thing to you guys. There is no wrong way per se to decompose a shape, as long as the measurements work. For our purposes, I'm going to show you the way that I would break down this shape. But if you see another way, try it out, see if you get the correct answer. So I'm noticing I have this rectangular shape up here and a kind of like trapezoid-y shape down here. So I'm going to split these two up. And now I have a rectangle and a trapezoid. Next, I want to fill in any missing measurements I have. Knowing that this is a rectangle, rectangles have equal opposite sides. So that means my newly developed red line must be 8 inches long. And these two are equal and opposite. So that must be 3 inches. Now I don't need or know any of these sides right here of my slants, because in a trapezoid we don't deal with the slants when we're finding the area. So now that I'm done filling in the missing measurements, I'm going to plan the work. So first, I'm going to find the area of the rectangle. Then I want to find the area of my trapezoid. And then I want to add those two together because the two shapes are together. So let's solve it. To find the area of the rectangle, remembering my formulas, I need to take the base times the height. And they gave it to me. I have 8 times 3. And 8 times 3 is 24, and my unit is inches squared because I multiplied together 2 inches. Next, I want to find the area of the trapezoid. Thinking back to our formula list, I know that the formula is 1/2 times the sum of the 2 bases times the height. And I have all this information. I have a base here that I like to call base 1 because it's my bigger one. I have base 2 because I filled it in. And I have a height. So I'm just going to fill those in. I have 1/2 times 30 plus 8 times 10. Now remember my order of operation rules. Solve my parentheses first. That gives me 1/2 times 38 times 10. Since this is a nice even number, I'm going to do that next and take half of 38, which is 19. And 19 times 10, because I bring that down, is 190. And since I dealt with area and I had inches, it's inches squared. So that was step 1 and step 2 of my plan. And now I have my last step. Add those two together. So I'm going to take my area of a rectangle plus my area of a trapezoid, and that was 190 plus 24, oops, flip-flop, you know what I mean, because adding doesn't matter order. When we do this, we get 214, and we keep our unit, inches squared. So the area of this composite figure is 214 inches squared. Now let's take a look at this composite figure. Again, I want to decompose the shape, fill in any missing measures, plan the work, and use my formulas. So this problem already gave me a nice dotted line if I didn't see it already. But what I'm going to do is I'm just going to highlight that line, make it a little bit more pronounced to show that I am decomposing the shape. And I've created a rectangle and a triangle. Now I'm going to fill in some missing measurements. So knowing that this is a rectangle, I know that the opposite sides are equal to each other. So down here is 10 inches. And across here is 8 inches. Now to plan my work. I know I need to find the area of the rectangle and the area of the triangle. So first, I'm going to deal with the area of my rectangle, then the area of my triangle. Then I have to combine those two. So I'm going to take the area and add them together. And that is my plan. So let's do it. I know that for the area of a rectangle, I need to find the base times the height. That's for area of a rectangle. And I know that the base is 10 and the height is 8. Or vice versa, but I just like to pick the bottom one. So I have 10 times 8, and 10 times 8 is 80. And remember, those units will be inches squared. Now for the area of the triangle, I know that my formula is 1/2 times the base times the height of the triangle. Luckily, I filled in a base for this triangle, and here it is. Here's my base. And the height, remember, is that perpendicular distance to the top of the triangle, to the top vertex. And that's that 4 inches. So now I can plug in some numbers, and I have 1/2 times 8 times 4. I can take 1/2 of 8, which is 4, and bring down the other 4. And that leaves me with 16 inches squared. Now finally, since I did this and this, I'm going to do this. So I have to take that 80 plus 16, and that's going to give me 96. And don't forget those units, inches squared. So this tells me that the area of the composite figure is 96 inches squared. Let's take a look at this example here. Normally I would decompose the shape and fill in missing measures, but from the looks of it, I don't see much that I can decompose per se. And I don't see any missing measures. But what they might want you to notice is that these two trapezoids are exactly the same. They have this shared base right here, both as their base 1. Both as their base 1. They have the same base 2. And their heights from base 1 to base 2 are exactly the same. So when I'm planning my work and I have two identical shapes, what I can do is I can find the area of one of the shapes, in this case it's a trapezoid, and then multiply it by 2. Luckily for us in this case, those are the only two shapes in this composite figure, so that will give us our answer. So that's pretty nice. So first, I'm going to find the area of the trapezoid, one of them, either one. So I'm going to take my formula. I have 1/2 times the sum of the two bases times the height, and I'm just going to fill in some numbers. I have still my 1/2, doesn't change, times my two bases, 22 plus 14, times their height, which is 8. Oops, 8. I'll put a little smiley face there because I messed it up. All right, so again, order of operation rules. I'm going to solve my parentheses and bring everything else down. This gives me 36, 22 plus 14, and I'm going to bring down an 8, not an H. Now, since this is a nice even number, I can take half of it because it's easy, and I'm going to be left with 18 times 8. Not as friendly numbers off the top of my head, so I'm going to do a little scratch work on the side. 8 times 8 is 64. 6 That leaves me with 144 centimeters squared, because our units are centimeters in this case. Now that gives me the area of 1. Now I have to do my second step. I need to take that 144 and multiply it by 2, which gives me 288. And I leave it with its units, centimeters squared. So that tells me that the area of this whole composite figure is 288 centimeters squared. Now that you've completed this portion of the video, please pause it and go to this unit's webpage and complete the Khan Academy practice. Once you've completed that with 100% success, do it a couple times until you hit that part. Then hop back on the video, unpause it, and we'll move on to the next section. Let's take a look at these two examples together. Notice that they have mostly the same numbers, but I want to highlight something very important about composite figures. So that's why we're going to use the same numbers. In both shapes, if I were to decompose, fill in missing measures, plan work, and use formulas, I'm going to notice that I'm dealing with a rectangle, and a rectangle, and a triangle, and a triangle. But the placement and use of those triangles are very different in both of those shapes. So first things first, I'm going to partition or decompose my shape, just make it easier for myself to see it completely visually. And on this one, we can't exactly do that the same way. I need to recognize that this side over here is completing that rectangle and also acting as a base for the triangle, just like here. Now I'm going to fill in some missing measurements. So just like in normal rectangles, opposite sides, I've got 10 inches here and 6 inches here. Even though it's not exactly attached, this distance, this empty gap between the two shapes is 6 inches, and this is 10 inches. So when I think about these two shapes, I need to consider that in one of them, this is two shapes combining together to make one big shape. In this example, it's showing me a shape with a cutout. This part of this triangle is really an empty space, and the shape is actually just like this. These are the sides of this shape. So when I am planning my work for step 3, when I'm planning my work in these two shapes, I know that I definitely have to find the area of the rectangle. I definitely have to find the area of a triangle. And in this example, because they're just two attached to each other, I need to add the two together. Now in this example, I also need to find the area of the rectangle, the area of the triangle, but since the triangle isn't an addition, but it's a cutout, I'm going to have to subtract it away because it's not actually there. It's showing us the measurements of an empty space. So I'm going to have to take that area of the rectangle and subtract the area of the triangle. I want you to go solve these two and pause this video. And once you're done, you may unpause and see the answers. Now that you've completed this section of the video, please hop onto the unit's webpage and do the Kahoot challenge. It isn't like a normal Kahoot. You are just going to go on and complete it at your own pace. Just a different mode of giving you guys some practice. Let me know what you think about it, and thank you for tuning in to this lesson on composite shapes.